Hey class, today we're going to finish up section 3.3. We started it in the last lesson, but we had a little bit further to go. So let's go ahead and get started. Our key question we're going to try to answer is, what kind of problems can you solve using dimensional analysis? And we did this for our homework. We worked out some simple one-step problems to kind of get a feel of how do we set up problems using the dimensional analysis method. So, in chemistry, as in everyday life, you often express a measurement in a unit different than the one that you're measuring in. For example, we might measure something in the lab as milliliters and we want to figure out what is it in liters. Or maybe we measure something as gallons and we want to get it to liters. Dimensional analysis actually serves as a powerful tool to solve these conversions by using something that is equivalent or a conversion factor. And we did this, like I said, for our homework, and we did simple unit conversions. Now, what we're going to work on today is multi-step problems. Many complex tasks in our life is best handled by breaking things down into smaller, more manageable parts. We can also take any word problems we're given and break them down as well. And dimensional analysis allows us to visually see and cancel our units and work and see these different steps. When converting between units, and we learned how to do this a couple lessons ago, we often have to use more than one conversion factor. Now, I taught you a simpler version of how to switch between units, but let's go ahead and check and solve another way. Here it says a diameter of a sewing needle is 0.073 centimeters, and what is the diameter in micrometers? And you might be like, well, we just have to subtract the exponents and move the decimal. If that method works for you, like I taught you a few lessons ago, stick with it. However, some college professors, if you plan to do any upper level science, is going to teach you the method that I'm about ready to teach you. And so I just want to give you some exposure. If you don't like this way, you are more than welcome to do the other way that I showed you. So let's go ahead and get started. Here, we need to know that micrometers is micrometer. And here we have centimeters. So you always start a conversion with what you know. So 0.073 centimeters. Now, in conversions, we want to be able to cancel our units. So most people are going to put centimeters on the bottom, like we did for our homework. And here, most people put micrometers on top. Now, if you look on the charts that are ever given to you, micrometers are 10 to the negative sixth. But note, that's 10 to the negative sixth meters equals 1 micrometer. Centimeters up here are 10 to the negative second. So that's 10 to the negative second meters equals 1 centimeter. So if I want to take this negative 2, this 10 to the negative 2, and connect it to my centimeter unit, I need to basically flip the sign. So if I'm going to attach this to the centimeters, this is going to be 10 to the positive second. Over here, I have a negative 6 on my meters, but I want to connect it to my micro, so I'm going to flip the sign to be 10 to the sixth. If you do this, you should get the same answer as moving the decimal. Remember, if you're on top, you multiply, and if you're on bottom, you divide. So in your calculator, you would plug in 0.073 times 10 to the sixth divided by 10 to the second. If you plug that into your calculator, you will get 730 micrometers. Now, some people like this method, some people don't. But again, you're more than welcome to use the other one. What I'm going to focus on here are the next two examples. These are going to be a lot more like what your homework is going to be over. So, one of the examples I give you that people have struggled with is how many eggs do you have if a dozen eggs has a mass of 660 grams and you have a total mass of 4.5 kilograms? These are multi-step problems. So, we have to figure out what are we trying to get to and how are we going to be able to do that? So, you kind of have to use some backwards thinking. This one's asking for how many eggs. So, here, eggs is what I'm trying to end with. So I have to ask myself, well, what in this problem will eventually allow me to get eggs? And so you have to read it. Do I know any relationship between eggs and another unit? Well, my problem says a dozen eggs has a mass of 660 grams. So we know eggs and grams are related. So grams should be able to get me over to eggs. But I have another number in this problem I haven't even worked with yet. And that unit right here says, but I have a total mass of 4.5 kilograms. So here I have grams and I have to use this kilograms. Well, we've learned how to go from kilograms to grams. And if you aren't familiar with this, please write this down. It's important. I expect you to kind of know it because it's the most commonly used prefix. There are 1,000 grams in 1 kilogram. So then we can go ahead and start our problem. 4.5 kilograms is the only thing that doesn't have a connection to something else. So we're going to use this to start off with, and we have to convert it. Well, my problem up here says I need to go to kilograms to grams first. So if I want to cancel kilograms, it's going to go on the bottom, and grams will go on top. Then we can use this conversion right here to convert. There are 1,000 grams in 1 kilogram. This allows me to get grams. So now I'm at the middleman. We can go to eggs. So here, if I want to go and get rid of grams, I need to put it opposite. So here I have it opposite, and I can go to eggs. Remember, this relationship came from the problem. We said a dozen eggs, which is 12. So 12 eggs has a mass of 660 grams. This allows me to cancel my grams and get to my eggs. Then you guys can plug this into your calculator. Remember, if they're on top, you multiply, if they're on bottom, you divide, and if it's a 1, you ignore. So this is the same thing as saying 4.5 times 1,000 times 12 divided by 660 because that's on bottom. And when you plug that into your calculator, you should get, you should get 81.81 eggs. Now you can't have part of an egg. So here, for your mass, you have about 81 eggs because I can't have part of an egg. So there we go. Here is another example that I have. And this one is not in your notes, but there's plenty of space on the bottom to kind of fill this in. It says, if a car is traveling 5 miles per hour, how fast is the car traveling in feet per second? Now, this is a unit for speed, and you can kind of see it's written with this little slash here. This can be rewritten as 5 miles for every 1 hour. And we want to get this to feet per second. Notice how I rewrote it. This is important and this will help you solve different problems. Now, the units on top are units of length. The one on bottom are units for time. So when you solve this, we want to convert miles to feet, and then we need to convert hours to seconds. So let's go ahead and set this up. 5 miles for 1 hour. And in order to cancel out miles, I need to put it opposite of where it's at. So miles needs to go on the bottom, and we want to get to feet. And so you have to ask yourself, do I know a conversion or a relationship between miles and feet? If you did last night's homework, on the paper, I told you that there are let's see if I've got that. I let you guys know that there are 5,280 feet equals 1 mile. And you'll get these, the same ones I gave in your homework last night, you will get these on your homework today. So we can fill that in, 5,280 feet in 1 mile. So this cancels out miles. When you read this now, feet is the only unit on top and hour is on bottom. So feet per hour. But I want it feet per second. So I now have to get my hours over to my seconds. So I got to do another line. If hours is on the bottom here, in order to cancel it, I need to put it opposite. So now this one's on the top. And you may not know how to go from hours to seconds. If you don't know, break it down into smaller pieces that you do know. So hours can be changed into minutes. The relationship here is 60 minutes in 1 hour. That allows us to cancel hours. Now I have feet on the top, minutes on the bottom, but I still have to get minutes to seconds, so we do another conversion. Note, if I want to cancel minutes, it's got to go opposite. So minutes will go on top, seconds can go on bottom. Here, my relationship between minutes and seconds is there are 60 seconds in 1 minute. So this allows me to cancel my unit for minute. Now, if you look on top, the only thing we didn't cross out was feet, and the only thing we didn't cross out on the bottom is second, which is exactly what we wanted, feet per second. Then you can go ahead and finish because I'm at where I want to be. Remember, top you multiply, so 5 times 5,280. If it's on bottom, you divide. Divided by 60, divided by 60. So 5 times 5,280 divided by 60 divided by 60. You should get 7.3 repeating. Now this is 7.3 feet per second, or you could say feet per SEC for second. Now, what kind of problems can you solve using dimensional analysis? Anything that allows us to go from one unit to another. And that's the end of 3.3. Because you guys are learning this at home, I'm going to do one more problem with you guys, just in case you need that little extra bump. Let's kind of go weeks to seconds. Oh, no, let's go to seconds. So 4,000 to weeks. If I wanted to know how many weeks are in 48,842 seconds, we always start with what we know. Well, I don't know how many seconds are in a week, so we need to break this down into more manageable parts. First, we can go seconds to minutes first. So we can say, in order to cancel out seconds, we need to put it on the bottom. Minutes can go on top. So what is this relationship? Well, there are 60 seconds in 1 minute. This allows me to cancel my seconds. From there, we can build upon this. Minutes can go to hours. So if I want to cancel minutes, it needs to go on the bottom. It's got to go opposite, and I can go to hours. Well, the relationship here says there are 60 minutes in 1 hour. That allows me to cancel minutes, but now I'm in hours. I want to get to weeks, so how do I get there? Well, I can go to days next. So notice, see how we're building. To cancel hours, it needs to go opposite. Days on top. So there are 24 hours in 1 day. This allows me to cancel hours, and now I'm at days. Well, hopefully you know how many days are in a week. So now we can do our last conversion. If I want to cancel out days, it's going to go on the bottom. A week can go on top. So if I say there are 7 days in 1 week, we can go ahead and equal this out because we're left with weeks. Notice these are all on the bottom, so we're going to be dividing this entire time. So 48,842 divided by 60, divided by 60, divided by 24, divided by 7. You'll get 0.08. So this is 0.08 of a week. So 48,842 seconds is only about 0.08 part of your week, so a very small fraction. Again, if you have any questions on your homework, please make sure you're messaging me. If you're at home and you're having trouble, you're always more willing to email me. I can help. You guys can come in before, after school, or we can even set up a Google meeting. With that being said, I hope you guys have a great day, and let me know if there's anything I can do.